Hey there, I'm Andy.
Hello, I'm Alexander.
Hello, I'm Daniel.
I will begin by offering a brief introduction about our client and our project. This is our team and our contact information, and these are the agenda topics for today. Our client is called CS Atlantic. They are a consortium which collects ocean data from Atlantic Canada. They provide an open access platform and data tools for academic and industry research. They also contribute towards education about oceans. Their business need is that they want to develop an interactive application to engage middle and high school students in learning about hurricanes and oceans. So to do this, they want to create an open, cross-platform applications for museums, libraries, and science centers across Canada to educate the general public about hurricanes and their impact on communities using open data resources. To address the business needs outlined by our client, we created an app called Educational Hurricane Dashboard. It is an educational cross-platform app on both Android and iOS designed for museums, libraries, and science centers to teach children about hurricanes with the help of quizzes. It includes an ocean map with many interactive visualizations. It also regularly collects hurricane data from NOAA and weather station data from CS Atlantic themselves.
The system architecture has 5 main components. Flutter App, which works on Android and iOS and can be easily configured on web if needed. SQLiDB, which stores data locally on each device and allows the app to work offline. PostgreSDB, which is a centralized database for storing all the data. Data sources, which are CS Atlantic Weather Station and NOAA hurricane data. And Nest.js API, which syncs and refreshes data every 24 hours on every device. The way those system components interact with each other is the following. The first step is that Nest.js API pulls new data from all data sources every 24 hours. Next, it formats all new data and stores it in the PostgreSDB. Next, every online device sends new quiz statistics recorded since the last sync to the API. Next, the API saves all the quiz stats to the PostgreSDB. Once all quiz stats from all online devices are synced, every online device fetches new quiz stats, hurricane, and weather station data from the API. The last step is that every device refreshes its local database with the new data fetched from the API. If the device is offline, steps 3 to 6 are executed after the internet connection is back. So essentially, all the syncing steps are executed once the device is back online. Since the Flutter application is the biggest piece of the project, we would like to explain how it works. The Flutter app has 5 parts. Widgets, which are components visible to the user. Managers, which are essentially controllers that perform business logic. Providers, which store application state for tracking quiz progress, map state, and other internal processes. Models, which interact with the SQLite database. And background services that send and fetch data from API every day. Now, we will demo how the app works. The app always opens in the landscape view to provide a more immersive user experience. When using the application for the first time, you can open the welcome alert by tapping a button with a waving hand. The welcome alert displays basic app information and a few tips on how to use the app. When the app is launched, you can see a hurricane map of the Northern Atlantic. You can zoom and pan on the map to select a specific area you're interested in. The map legend explains what each color means. To access it, you can tap the info button. Here, you can see that each hurricane category has its own color. Going back to the map, when you click on the hurricane, you'll see different hurricane details, including name, date, hurricane category, and other metrics. Each circle on the map shows the progression of the selected hurricane with a frequency of 6 hours. The circle radius depends on the hurricane's wind speed, meaning the higher the wind speed, the bigger the circle radius. There is also a date selector at the bottom, which displays hurricanes for a specific year. If you select 1975, you will see all the major hurricanes that happened that year. The app also has a search feature that allows you to search hurricanes by name or year. As you type, you can see the updated search options. Once you select a search option, you will see hurricane details for the hurricane you searched for. When you tap the button with the sun icon, it toggles the map color mode. The dark mode has higher contrast, so visually impaired users can see the colors more clearly. Currently, the application has two modes, Hurricane Map mode and Weather Station mode. To toggle the modes, use the Switch Map Mode button. Once you switch the mode, you will see different weather stations for Atlantic Canada. When you click on a specific weather station, you will see a drawer with the weather station ID and different metrics, including max temperature, max wind speed, average pressure, and max wave height for the selected date. The images represent temperature and wind speed. The latest date available for a weather station is selected by default when you open weather station details. To change the date, you need to long press on the graph and move the crosshair to a specific date you're interested in. You can also zoom and pan in the graph to increase the accuracy of your selection. There is also an educational screen that provides general knowledge about hurricanes, weather stations, and oceans. To access it, you need to tap a button with a book. The educational screen has 5 sections about what hurricanes are, basic hurricane terminology, hurricanes in Canada, hurricane categories, and basic weather station terminology. You can use all the features that we just demonstrated to complete quiz questions. To access quizzes, you need to tap on the quiz button. To select a question, you tap on the one you want to complete. Once you select a question, you can see different answer options. You can move to the previous or next questions using the navigation buttons on top. Or you can just go back to the quiz list to select another quiz question. To find the answer, you need to use the map or the educational screen. To give you a gist of how it all works, we'll answer the following question. What was the most active hurricane in 1979? To answer this question, we need to use the map with hurricanes. You should use the date selector to select 1979. Then, you need to use a map legend to see what each color means. Here, you can see that purple is for Category 5, which is the most severe one. When looking at the map, you will notice there is only one hurricane with a purple segment on it. When you tap on that segment, you can see the details of this hurricane, including the name, which is the answer. As a side note, you can see that the quiz question is in progress because the quiz button is red. When you go back to the quiz question, you can now answer it. Once you answer the question, the app shows you the total number of correct and wrong responses for all the users. If you answer the question incorrectly, it shows you the correct response as well. Using a similar approach, you can now complete quiz questions involving other features of the app, like weather stations or educational screen. Our app has helped our client in many ways. We created an all-in-one educational app that eliminates the need for external textbooks or materials, providing a more efficient and a cost-effective learning experience for students. Fun quizzes, along with accessible approach to presenting data, keeps students engaged and enhances the learning process, resulting in better retention and understanding of the material. Cross-platform functionality of our application enables it to be accessed by a wider audience. Also, offline capability of our app ensures that users can access and use it in areas with limited or no internet connectivity. We used many technologies in the project. For the front end, we used Dart and Flutter to create a cross-platform app that is configured to work on iOS and Android. We also used Mapbox for map visualizations. On the backend, we used TypeScript and Nest.js to create our API. For the databases, we used SQLite to store data on mobile devices and Postgres for our centralized database. Other tools that we used include Docker to run Postgres database, Figma that we used to create app prototypes, and GitHub for effective team collaboration and project development.
We encountered many challenges that helped us learn a lot during the app development, such as additional configurations for different platforms, creating advanced custom UI widgets and graphs to enhance app interactivity, full Flutter codebase refactoring to improve app state and data management, map rendering optimizations for smooth UX, and asynchronously parsing massive data files that cause memory issues. To conclude, our team has successfully created a complex cross-platform educational system, achieving a high satisfaction rate from the client. We learned a lot of skills and honed our knowledge of the technologies used in the project, and we're very excited to use our new skills to take on new challenges that the future holds for us. If you have any questions, please contact us. Thank you.